Hey everyone, welcome to Tech in 5. This is your host Charlotte again. Rockets are known to be one of the most complex technologies of human inventions, but SpaceX takes it a step further by making it reusable. But how does a company build such great rocket? Let's find out. When Elon Musk's SpaceX, short for Space Exploration Technologies, got into the rocket game, it promised reusability, lower launch costs, and easier access to space. In April 2014, SpaceX signed a 20-year lease to use NASA's Launch Pad 39A, the very same launch pad from which every Apollo mission, other than Apollo 10, and a host of space shuttle missions were launched. To support the Falcon 9 launch, SpaceX had to customize the pad. It refurbished the sound-suppressing deluge system, which uses water to protect the rocket from its own acoustic energy at the moment of launch. It also replaced electronic components, power and plumbing lines, and upgraded the liquid oxygen storage system that is used to fill the rocket's tanks before launch. The metal octaweb structure that houses the Merlin engines is vital to the Falcon 9's first stage. Earlier versions of the rocket had 9 engines arranged in 3 rows of 3. With the octaweb, 8 engines are clustered in a circle around a central one. The different engine arrangement is more than just aesthetic. The octaweb reduces the length and weight of the Falcon 9 thrust structure, simplifying the rocket's design and assembly. Streamlining the manufacturing process ultimately keeps launch costs down. An interstage is vital to any multi-stage rocket. This section connects the first and second stages and also houses the engine of the second stage, protecting it during the first phases of flight. At the right moment, the interstage separates the 2 stages, allowing the second stage to fire safely. This is called the moment of staging. Separating rocket stages can be a tricky business, but the Falcon 9 makes it simpler. While the majority of rockets use a complicated pyrotechnic system of explosive bolts to separate stages, SpaceX uses an all-pneumatic stage separation system. This system can be tested on the ground and also means staging is less jarring to the rocket. Hey, if you're enjoying the video till now, please consider giving us a thumbs up. You may also support us by finding the donation link in the description below. So let's continue. The power behind the Falcon 9 is the Merlin engine, which is built in-house by SpaceX. The rocket boasts 9 of these engines clustered together in the first stage, while the second stage contains a single Merlin that's modified to fire in the vacuum of space. These engines burn a combination of rocket-grade kerosene called rocket propellant 1 and liquid oxygen. On a typical Falcon 9 launch, the first stage engines burn for 162 seconds, and the second stage engine burns for 397 seconds. The Merlin engine is incredibly powerful and one of the most efficient engines ever built. Having 9 of them in the first stage also offers some built-in safety. On other rockets, if an engine fails during launch, the lost thrust can destroy the payload's chance of successfully reaching orbit. But the Falcon 9 is designed so that 2 of the 9 Merlin engines in the first stage can fail, and the launch won't be affected. The healthy engines can burn longer, picking up the slack to save the mission. SpaceX doesn't build the Falcon 9 in Florida, it's just assembled there. Most of the rocket's parts are built elsewhere, notably on the other side of the US, in the company's factory in Hawthorne, California. This means the components, including fuselages and engines, need to travel around the US by truck to various test stands before eventually ending up at NASA's Kennedy Space Center in Florida. Once in Florida, the pieces are mated in SpaceX's custom-built horizontal integration facility, a large hangar within sight of Launch Pad 39A. The most exciting part of any Falcon 9 launch might be the landing, specifically that of the first stage onto a floating barge. The Falcon 9's first stage includes 4 small carbon fiber landing legs stowed flat against its fuselage. After the rocket goes through staging, the first stage begins its fall through the atmosphere. Cold gas thrusters near the top flip the rocket around, so it's upright. Then the stage engine fires briefly, just enough to slow its fall. As the stage approached its target, the legs deploy. In the very final phases of its descent, 3 of the 9 Merlin engines fire one last time for what SpaceX calls the boost-back burn. The stage slows even further, almost hovering as it makes a soft touchdown. This landing sequence is entirely automated, with the rocket stage responding to real-time data. So far, the Raptor has not flown and has only been successfully test-fired on the ground. Nonetheless, SpaceX has big plans for it. This is the engine that will power eventual missions to other planets, starting with Mars. The company recently unveiled its design for a planned interplanetary spacecraft, and in its current incarnation, uses a whopping 42 Raptor engines in the launch vehicle's first stage to get this heavy spacecraft off the ground. But before it launches to Mars, Raptor will make its debut on an upgraded version of the Falcon 9. After its successful landing, the Falcon 9's first stage is returned to the Horizontal Integration Facility, where it can be checked out, refurbished, and readied for another launch. Reusing the stage is much cheaper than building a new one for every launch. The SES-10 mission in March 2017 was the first time a core stage of an orbit-capable rocket has been reused, and the cost was substantially less than half of what it would have cost to build a brand new stage. Elon Musk has likened single-use rockets to single-use aeroplanes. If an airline had to scrap a Boeing 747 after every flight, then the cost of flying would be prohibitively expensive for the average traveler. But aeroplanes aren't single-use, they're refueled for another flight. If a rocket can be refueled like an aeroplane, then the enormous cost of a spaceflight could drop to a fraction of what it is now. And imagine the implications of that. Thanks for watching this video. For more such in-depth analysis videos, consider subscribing our channel. This was your host Charlotte, and I'll see you next time.